The other thing that I thought of when I was hearing your comment just now is that the array controllers themselves became servers.
Oh, of course.
So you had a motherboard inside the array.
You couldn't compete.
Right.
The tick of the Intel clock, right? The cycle. 18 months is just too fast to develop a new architecture for an array controller, especially the high-end array controller. So the entire theory of the case in the early days was that there would be a plethora, there's an old word, a large variation in the number of storage controllers, their size, their vendors, etc. in the environment. That the basic storage utilities that people absolutely required to be able to run their data center productively, everything from data replication to migration to high availability to you name it, disaster recovery, all of these would move up the layers, right? They would move up into the network, and therefore they would move up into software. And that software would define, to use a very commonly used word, would define how the various parts and components, which were essentially commoditized, would be incorporated into the storage architecture. The key technologies that were going to drive that were the very rapid increase in the capabilities of the standard servers, of the chipsets and of the capabilities of the servers themselves. The theory of the case was that eventually the relatively large software requirement in order to be able to control that software stack would be a drop in the bucket compared to the basic capabilities of the machines. And if that were the case, then the software would not only be able to live anywhere, but in essence it would live everywhere. Right? And the software itself became the fabric of the network. It wasn't, the port fabrics and so on and so forth. It was that the software, the basic capability, the platform ran the task. Right? Software-defined storage, if you like. Storage virtualization is essentially the same thing.